This is a CCEA A2 Applied Maths paper, and this is question 5 as a question moments. So just to show which paper we're on, we're in June 2022, and this is question 5 then. So figure 3 shows a uniform rod AB of length 4 meters, so that's 4 meters, and mass 8 kilograms. So we're going to have 8G acting down there. One end of a light inextensible string of length 5 is attached to the rod at the point C, where C is 1 meter from B. The other end of the string is attached to the wall at a point D vertically above A. The rod rests in equilibrium horizontal position. Complete the diagram below showing all the external forces acting on the rod. So we're worried about what's acting on the rod here. So we're going to have tension here down the middle, because it's a uniform rod, I think. We have 8G acting this direction here. And we can either have our action or Y here, or our reaction then at the hinge. Sometimes best to think, what would happen here if this wall and hinge disappeared? Well, I think the rod would head that way, and it would also drop down. So this reaction then is holding it in this direction here. And I'm going to call this angle here then alpha that we have in there. So complete the diagram showing all the external forces acting on the rod. We have this one here. We have this one here. We have this one here. Find the magnitude and direction of the reaction on the rod at the hinge. So it's effectively that R and that alpha that we want to try and work out. We can do a wee bit of Pythagoras here to work this out and get our angles of different things that are working, because they've told us that's 5. We know that that's 3, because remember the thing was 4 long and it was in 1 meter, and then that's our 4. So if we put our theta there, we know then that sine theta is going to be opposite over hypotenuse, which is 4/5, and we know that cos theta is then 3/5, and that's going to help us whenever we go to take moments and different things about that. So we're effectively going to do everything going up equals everything going down, everything going left equals everything going right, and then we're going to take moments about a certain point, and that'll help us work in from there. So let's bring our diagram back up here, and hopefully you can see. So I'm going to take moments then about the point A. Our point A here, and it's going to be clockwise equals anti-clockwise. So bringing it clockwise again, the pin's being put in here effectively, so that 8G is bringing it down. So the distance, that's 2 times 8G equals 3, because that distance is there, times T, and we're trying to effectively resolve this T in this direction here, perpendicular to the rod, and we know that that's theta, so we're not going to cross it, so it's going to be sine theta. You can work out your theta, of course. It ends up being what, 53.1 or something like that, but you never actually need the theta. You only ever need sine theta or cos theta, and it's much handier if you have them in that format there. So we're going to have then 16G is equal to 3 times T times 4/5. If we rearrange that then, so 16G, 3 times 4/5, so it's going to be 12/5T. If we times that by 5, we're going to get 80/12 and divide by 4, so T then equals, it tidies up to give us 20G/3, and that gives me 65.3 newtons. Another thing that I'm going to do is resolve everything going up equals everything going down, everything going left equals everything going right. So everything going up equals everything going down. Again, let's get back to our diagram here, and hopefully we can see. So what do we have then going to go up? So our R, we're not going to cross that, so it's going to be R sine alpha plus T sine theta equals 8G. So again, do we see that? The T's going that way, so we're not going to cross the theta. We have that, so we're not going to cross the alpha, and then 8G going straight down then from there. So my r sine alpha, then I can tidy things up a bit. R sine alpha equals 8g minus t upon 4/5. And of course I know what t is as well anyway. So that equals 8g minus 20g over 3 upon 4/5. They're both kind of things of g. Again, if you put that into your calculator, you get 8g over 3. Sorry, you weren't able to see that bottom bit there. Then we have everything going left equals everything going right. So can we see then that this 8g is going to have no effect? So resolving my r in this direction here, that's going to cross the alpha. So r cos alpha equals t sine theta. Sorry, t cos theta. I hope I said the right thing. I'm going to cross, so r cos alpha t cos theta. So my r cos alpha is equal to 20g over 3. That was our value we got for t, and then times 3/5. So that's a bit nicer because the 3's cancel there, the 20g and the 5 cancel. So my r cos alpha then gives me 4g. Hopefully we know the trick. R sine alpha over r cos alpha is going to give us tan alpha, so that can help us work out our alpha, and then I can work out the r then after that. So let's change pages, hopefully on the other side. So as we had 8g over 3 was our r sine alpha, and then we have 4g over here. The r's cancel. Sine alpha over cos alpha of course gives us tan alpha, and that all cancels in to give me 2 over 3. If we times both sides there, if we times top and bottom by 3, it gets rid of the 3 there and comes down to the 12. 8 over 12, the g's cancel, and we have 2/3. Shift tan 2 divided by 3 equals 33.69 or 33.7 degrees. If we then put that back into one of our two equations, for example, we know our cos alpha is 4g, we can work out our r. So r cos 33.7 equals 4g, and then r, if you put it into your calculator, divide by cos 33.7, we're going to get 47.1 newtons.